Hello, and this time I'm talking about set theory and specifically how it relates to filling in of Venn diagrams. Now, there's lots that you can do with this, so this is just a little taster with two examples, but hopefully it will be useful. And if there's things I don't cover that you come across, you can let me know in the comments, and I can make another video. And I will be proactively making other videos about other aspects of this, so you don't need to worry too much. But if I don't, for a long time, then you can let me know and I can try and sort it out. Right, before we sort of dive into filling in the Venn diagram, then let's just have a look at some of these symbols. So first of all, this squiggly E shape thing is the universal set. So that is, for this question, what is everything we're dealing with? If it's is it all the cards in a deck of playing cards, or is it all the certain numbers 1 to 10 or something like that? So we're not having to deal with the whole universe every time that we deal with it. It's like, what's the universe for this specific question, okay? And the box in our Venn diagram contains everything that the question is dealing with, okay? And then inside we've shown a circle for each of these sets, which are defined by just this capital letter. And the squiggly brackets here, either you just list it out, so you could say D is, and then I've forgotten how to do squiggly brackets, like that. And you could just list them out. Factors of 20, 1, 2, 4, 5, 10, and 20. Those are all the factors there. Oh, no, squiggly bracket, and make sure that looks like a 2. And squiggly bracket. So these brackets, you can either say just the list of the members, just like a register, or you can write a rule that defines all of the members. So it might be, you could have squiggly bracket, the planets in our solar system, and that would then give you 8 entries for each of the planets. Okay, so what else have we got? We can combine sets. So if we say D and then an N sort of shape and E, then this means the intersection. That means anything that's in D and in E at the same time, which is the overlap in between the two. Whereas if we say the D and then a U shape and then E, like we've got here, then this is the union. And this is saying anything that's both D and E, but also the things that are just D and also the things that are just E. Or the other way to think about it is you can say D in union with E is everything in D, literally every single thing that complies with D, and then all of the other E things that we haven't already listed. The complement of a set, E dash or D dash or whatever it might be, means everything except. So E is all of the stuff in the E circle, of course, and E dash, if I change color, is everything else. It's everything not in E. So everything that's not in anything, just in the universal set on the outside, and all the D and the F, but not the bits of D and F that contain E. And you can put that complementary set on these things. You can sort of say, what is that? And then say not. So you would work out, if you're doing that, F in union with D would be all of this. And then if you said not on that, everything except that, then it would be just this part of E and the bit around. Okay? Now, I might have forgotten some symbols there, but if they crop up, we'll deal with them as they come along. And if there's something that you found, because we haven't mentioned subsets, which is that symbol, and member of, which is the same symbol but made into like the letter E. Oh, that's a terrible picture. So sort of a stretched out sort of C shape with an E mark in the middle. I just can't do it nicely. There we go. That's member of, and that's subset. So you could say 1 is a member of D, like that, okay? And a subset is when a set is completely contained in another. So if you've got a set, and then there's a little group of numbers which make another set, but they're all members of the larger set, then that's called a subset. Right, let's crack on with this example, otherwise this video is going to be horrendously long. When you are copy and complete this Venn diagram for these sets, when you're filling in a Venn diagram, try and start in the middle, okay? Because then you're not having to worry. If I said, let's look at this little section, what numbers are members of D and E, but not members, it's just too complicated. Fill in the F, and then when you're looking at, you can then look at D overlapping E, and you've already got the things that are also members of F. So very quickly, I'm just going to list these out. It's much easier for this question just to make the lists and then compare the lists, but sometimes you just do it by thinking about it, which is not a problem. The factors of 20 are 1, 2, 4. We just had this. I've forgotten them already. That's a 4. Gosh, that's terrible. Let's try that again. 4, 5, 10, and 20. The factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24. And the first 7 even numbers, 2, 4, 6, 8, 10, 12, and 14. So let's just run through. What is in all lists? Well, 1 isn't, but 2 is. 3 isn't, but 4 is. 5 no, 6 no, 7, 8, 10 no, 12 no, 20 no, 24 no, 14 no. No, so it's just 2 and 4. I'm going to rewrite those a bit better, hopefully. It's just a little tiny box there. 2 and 4, that's better. And now when we look at D intersecting with E, we can just run through, and anything we've already got written down, now obviously if they've given 1 for us, but that might not exist, so we just like anything that is in both of these that we haven't already got in here. So 1 they've already put in, we've got 2, we've got 4, 5 doesn't, 10 doesn't, 20 doesn't, that's it. Okay, D and F, we've got 1 doesn't go, 2 we've got, 4 we've got, 5 doesn't, 10 we've got, they've written in for us, 20 doesn't, that's it. E and F, we've got 1 doesn't, 2 we've got, 3 doesn't, 4 we've got, 6 we have not got, so we'll add that into there. 8 we have not got, so we'll add that in. 12 we've got, they wrote it in for us, and 24 doesn't. Now we can fill in the individual boxes, or not boxes, but little areas, with anything left in the D list that we haven't already got. So we've got 1, 2, 4, we need 5, we've got 10, and we need 20. For E, we've got 1, 2, we need 3, we've got 4, 6, 8, 12, we need 24. F, we've got 2, 4, 6, 8, 10, 12, we just need the 14. Now we're not done yet because actually we still need to populate what goes around the outside, numbers that are not in D or E or F. And as we've only got numbers up to 24, we'll just go through them in order. We've got 1, we've got 2, 3, 4, 5, 6, we need 7, we've got 8, we need 9, we've got 10, we need 11, 12, 13, 14, 15, 16, 17, 18, 19, we've got 20, 21, 22, 23, and we've got 24. List the elements in F in union with D. So that's anything in F and anything else in D that we haven't already listed. Now, when it says list the elements, it means write down a list of all the members. So again, like the register of everyone in this. If it had said N of F in union with D, then that is saying the number of, and this is what part C is saying, how many elements are there is the number of, but sometimes they write it like this, N of a set would be how many members are there. But this is wanting a list, so we can just do it. And the way I like to write it out is, I forget about the union for a second, all of F is going to be in it, so I'm just going to write down the whole of F. So in order, 2, 4, 6, 8, 10, 12, 14, and then in union with D means we're going to have anything else that I haven't already got written down from D. So I haven't got 1, but I've got 2, 4, I haven't got 5, I've got 10, and I haven't got 20. So then I know I've got everything. Now you could just look at the circles, 25, 1, 2, 4, 10, 6, 12, 8, and 14, and write it down from the circles. It's up to you. How many elements are there in E not? Well, let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And also the parts of these that aren't in E, 13, 14, 15, 16. It's always a good idea just to check. So if I add up the numbers in E, 1, 2, 3, 4, 5, 6, 7, 8, and add it on, then I do get 24, which is my total number of members. So I'm pretty confident that I haven't accidentally put a number in twice, because that's very easy to do, accidentally, when you're filling D in, just go, oh yeah, 1 needs to go in, not seeing it there, and then miscount and end up with too many and get everything wrong. I know it doesn't ask for it, but I'm just going to also do the intersection. So if it had asked for F intersects D, then that is just the overlap, in which case we look at the diagram and it's just that overlap between F and D, so it's 2, 4, and 10. So if you are asked for the intersection, it's just the things that are in both of the sets. Okay, let's look at the next example. And here we have letters of the alphabet, so all the letters of the alphabet. V is vowels, A and B sets, and then we're going to draw a Venn diagram to show the sets V, A, and B. So what we can do is, as we've got 3 sets, we know that we can draw it like this. Big overlaps so that we know that we've got plenty of space to write lots of letters in. Now, there might be situations, I haven't looked at the sets yet, where they don't all overlap. Maybe it's actually that one of the sets shares with both of the others, but these 2 sets don't have anything to share. In which case you might draw it differently, but it's okay to draw it in this respect. If there is one that's empty, we can either proactively leave it empty, or we can label it as saying it's the empty set. That's another set theory symbol. If you just put 0 in, say, oh, it's empty, well, actually, that's not what you've said. You've put the number 0 in. That might be a value. That might be the name of a member. The 0 goes in that one. So if you want to say this set has nothing in it, it is empty, then either leaving it blank might be appropriate, or a sort of an O with a line through is the symbol for this is empty. There's nothing in it. And those 2 ideas of 0 and nothing and emptiness are very different, so you've got to be careful. Anyway, let's have a look through. Let's label them. So V there, A there, and B there. And again, let's work from the middle. So what vowels are in A and B? Well, we've got E and U, and we've got A and E, so E is in both. Okay, and then we're just going to look at 2 at a time. So what vowels are in A? Okay, so that's A and E. Well, we've already got E, so we just need A. What vowels are in B? It's E and U, but we've already got E, so we just have the U. And then what's in A and B? Well, if we look at what's in A and B, they share a D and an E, but we've already got the E, so D goes there. Now, everything left in V goes here, so A, E, I, and O. A is A, B, C, D, E. And this one is D, E, U. So actually everything it has is shared with something else. That's shared with A, that's shared with everything, and that's shared with vowels. So this is an empty set. So we could leave it blank, or we could put that symbol in. I'm tempted this time to leave it blank, but you do need to check carefully how the question's worded, in case it wants you to be clear that we shouldn't have drawn it like this. Maybe we would have drawn it as a sort of like a set that went like this in between the 2 circles and labelled B. But then it would be confusing between the label of capital B and little b. So I quite like it like this, and making it clear that that's empty. Everything else in the alphabet needs to go on the outside. So A, B, C, D, E, F, G, H, I we've got, I've gone to capitals, shouldn't do, no, I've got rid of that. Let's backspace. So E, F, G, H, I, J, K, L, M, N, O we've got, P, Q, R, S, T, U we've got, V, W, X, Y, and Z, or Z. But it doesn't rhyme as well. So we've got all that filled in, excellent, and now we can list the set of V in union with A. So remember, if it's in union, I'm going to say, I'm just going to list all the V, so A, E, I, O, U, should put commas in just to be clear, and then anything extra in A, well, yes, any extra in A is B, C, and D, so add that on there. That U doesn't, in an exam, that might look like an N, so make it that more clear. Describe the set V'. Well, it doesn't want you to list the members, it wants a description of everything that's not vowels. So you could say everything that's not vowels, or you could say consonants, because in this case, there's only 2 things in the alphabet, vowels and consonants, so you could write that down, but just be careful, that won't always work if, if you're, like, let's say if you've got prime numbers, square numbers, and cube numbers, for example, and it asks you that, you couldn't say, if that was prime numbers, how do you describe prime not? You couldn't say square numbers or something like that, because, or just some other type of numbers, because there isn't a word that encompasses everything that isn't prime. But in this case, because it's binary, you're either a vowel or not. Well, you know, Y I know is a bit weird, but that is definitely a consonant. If you play countdown, that comes out from the consonant list, so it's definitely a consonant. Then you can use that word to describe it, but just be careful. Perfectly acceptable to say everything that's not, and then just say what that is. Is B a subset of V in union with A? Well, this is what we were saying before. Yes, it is, because there is nothing. If it is, then everything in B should be a member of this. And we've written out the membership of V in union with A, and we've got D, and we've got E, and we've got U. So everything that B contains, there's nothing that B contains that's outside of that union. So is it a subset? Yes, it is. And you might have to put words on that if they wanted that. Hopefully I've not overwhelmed you with these examples, but if you have any comments, then the comment section is for those. So put them down, and I will do another video if there's a big enough thing to deal with. Obviously, I said before, there's lots of different things with set theory, so no doubt there will be other videos coming out with different aspects of set theory in it. But for now, I think I best leave it. It's quite a long video, and I'll say ta-ra.